Hello my dear students, welcome to Learning Chemistry is Easy and Fun. The topic Logarithms Part 2. If you have not seen Part 1, request you to first go through Logarithms Part 1 where we have dealt with the fundamentals and the rules and the laws which we apply in logarithms, and then come on to Part 2 of the video. Now, in order to be able to do complex calculations, for example, I have log of 0.358 into into 80 divided by 36.64 square root. Now this is where we find logarithms very handy and very useful, because under your normal mathematical calculations, unless you are very good at working and mental calculations, at least I can't do those without using logarithms. So if you have a calculation like this, or let's suppose you have not even a log, let's suppose you just have a calculation like this to solve, logarithms is what comes in very handy in order to do calculations like this. In order to apply logarithms, you need to understand two things. There are two parts in a logarithmic value: the characteristic and the mantissa. As I mentioned in Logarithms Part 1, you need to have the logarithmic table handy. Usually you will find it behind in the last part of your in the appendices of the textbook, or you will find logarithmic tables separately. So if you haven't got hold of them, please get hold of a 4-figure logarithmic tables handy before you proceed with this video. Characteristic is the part which tells us how many digits are there before the decimal, or what is the position of the first digit after decimal in a logarithmic value. Characteristic depends upon whether the number is greater than 1. Greater than 1 means if it has a digit before the decimal, or if the number is less than 1, that means there is no digit before the decimal and our number starts like 0.04238. If I have a positive a positive characteristic, meaning to say the number is greater than 1, so my characteristic is positive. Log of 42.38. I'll explain this in two ways. You can understand in any of the way. Log of 42.38 can also be written as log of 4.238 into 10 to the power of 1. Converting it to a number which is having one digit before the decimal. I'm not going to use technical terms because I don't want to confuse the students. So 4.238 into 10 to the power 1. I shift the decimal to one place before. The power to which 10 is raised over here gives me the characteristic. So this becomes 1 point. Now look at your logarithmic tables. At the end, you have the logarithmic tables listed as, you will find two digits over here starting from 10, 11, 12 and going up to 99. You have 10 digits over here, 0, 1, 2, 3, 4 going up till 9. And then you have a third column, mean difference, 1, 2, 3, 4 going up to 9. When you have to see the logarithmic value of a number, now we have taken care of the decimal aspect of this by putting the characteristic. Now look for 48. In this column, look out for 48. See the value under 3. So you look out for 48 on your logarithmic table. 3 over here and then 8 over here. Whatever value you get under 3 and then 8, please add it up. So we have 42 under 3 gives us 4263, and 2 gives us a 2. So 4263, my value may not be accurate, 4263, and the mean difference comes out as 2. Add them up. So 3 plus 2 gives me a 5, 4265. These log values, sometimes there is a small difference, varies from the textbook, from the authors, from the publishers. So 42 under 3 and 8 comes out as 4265. This becomes my characteristic. This is the mantissa. Mantissa you see from the table, the characteristic you determine from the number. If you are finding it difficult to convert it into an exponential number, just you can also say, like, let us suppose I have log of 65.34. If I want to determine the characteristic of this, the characteristic of this number is 1 less than the number of digits before decimal. So now there are 2 digits. 2 minus 1 gives me 1. So the characteristic is 1 decimal, and whatever is the mantissa. Log of 984. What will be the characteristic of this number? Yes, there is a decimal over here. So there are 3 digits before decimal. 1, 2, 3. 3 minus 1 gives me 2. So the characteristic of this number is 2. And then decimal, and then you determine the mantissa. Look for 98 under 4. Now there is no 0 in the mean difference. So 98 under 4 gives you the mantissa, and that makes the full log value. So log value of 42.38 is 1.4265. So there are 2 ways that you can determine the characteristic if it is a number greater than 1. Either shift the decimal place, so you have 1 digit before decimal, or you take 1 less than the number of digits, not the digits, the number of digits. So 1, 2 digits before decimal, minus 1 gives me a 1. So the characteristic becomes 1. Mantissa is relatively easy because you just have to see it from the table. It's the logarithm that you need to practice. So, the characteristic. So let's suppose I have 0.35, this becomes a number less than 1. Log of 80. What will be the characteristic of this? Yes, 1. Log of 9284. What will be the characteristic of this? I'm just writing the characteristic, please. The mantissa comes from the table. 1, 2, 3, 4. There are 4 digits before decimal. So the characteristic becomes 3, and then you write the mantissa. What if it is a number less than 1? So I have taken 0.04238. Again, convert it to a form where you have 1 digit before decimal. So 4.238. You've shifted the decimal 10 to the power minus 2, right? So this becomes 4.238 into 10 to the power minus 2. Now if you notice over here, this is a negative number. So my characteristic is a negative value. How do we represent a negative value in logarithms? By putting a minus sign on top called as the bar. So we say 2 bar point. Now again, to see the mantissa, 42 under 3 and 8. 0.4265. As simple as that. This is the log of 0.04238. Now, just now we were about to take the example of log of 0.358. 0.358. So, if I shift the decimal by 1 place, this becomes into 10 to the power minus 1, right? So the characteristic of this becomes bar 1. The log value of this becomes bar 1 point. Look out for 35 under 8 in the logarithmic table, and that is the log value of 0.358. Try one more. Log of 0.0098. Now you shift the decimal 1, 2, 3. 3 places. In other words, my log value will have a characteristic of 3 bar. point. Now how do you see the logarithmic table? Our tables are starting from 10. So our first two digits here are 98. So you look out for 98 under 0 becomes the log value of 0.0098. Go ahead, find out the log values of these numbers. I shall post the answers in the comments once I get one or two answers and the students attempt it, or you can send me your answers on the comments and I shall revert to you. Now, how do we use these logarithmic tables to solve difficult questions? I'm going to take up a question over here which shall cover the different aspects, and I have done the log values earlier so that the video doesn't extend to too long. So I've taken over here log of 0.3561, sorry, not log of. I have an expression here to solve. X is equals to 0.3561 into 38.62 divided by root of 39. Now I have to solve this. These are the type of calculations that you will see in your physics, chemistry, etc. So first things first, let's take log on both sides. So log x is equals to, I have log of 0.3561 38.62 root of 39. Correct? Simply taking log on both sides. Now, next step is to expand. Now, from your knowledge of the first video, these are being multiplied. So, what sign will they have when I write it in an expanded logarithmic form? 0.3561, yes, plus log of 38.62. Again, going back to what we'd done earlier. This is root of 39, but it is in the denominator. So what sign will it acquire now? Yes, minus log of root 39. Now this is again root 39. We don't know how to solve the root values using logarithmic tables. So let us expand this further. Log of 0.3561 plus log of 38.62 minus. Now this is root 39. That is the same as 39 to the power half. Going back to our previous video, minus half log 39. Right? Now, next step. I'm going to put the log values now, and we shall always try to put the log values in one step rather than spreading it over two steps so that there is no confusion. Let's write the characteristic first. Yes, bar 1 point minus half into, half remains as such, 39, the characteristic is 1. Now, get hold of your logarithmic tables. Give me the values of 35 under 6 and 1, 38 under 6 and 2, and 39 under 0. As I said earlier, sometimes there may be a difference of 1 or 2 digits in the log values. Don't worry about it. 5868, and I have here 5911. Right? So this part I will solve here. Half of 1.5911. This is your normal mathematics. Don't worry about it. 2 times 7 is 14, 2 times 9 is 18, 2 times 5, 2 times 5, and this becomes a recurring decimal, so I write it as 0.7956 rounded off. 1 bar 0.5 5515 plus 1.5868. Just use normal mathematics over here. This is not a big deal, because this is where I find the students getting intimidated and like, oh, this is too much of calculation. Once you do 2 or 3 questions, it's a cakewalk. It's very, very easy. Now just add them up as you would do under normal mathematics. 513, 8, 11. Now 1 gets carried. Now see over here, bar 1. If you remember, I told you it's a negative value, right? So I have a plus 1, I have a minus 1, and again a plus 1. Again, use the normal rules of mathematics. 1 plus 1 gives me a 2. 2 minus 1 gives me a 1. So I have 1.1383, right? Now this is again a mathematical number. Just take away. So I have 1.1383 minus 0.7956, as you would do under normal mathematics. That is what you have to do. So this gives us 0.342 and a 7. Have we reached the final answer? No, we haven't. Why? Because this is the value of log x, 0.3427. What do we have to find out? X, right? We took x as this. Then we took logarithm. So what do we do in order to find x? Yeah, simple. Take antilog. So we write over here, taking antilog. Now you will see the anti-logarithm table in the same logarithmic tables that you have. If you see your anti-log tables, they start with a decimal number. So 0.3427. Why not this number? This number will give you the position of the decimal, where you have to put the decimal. So this becomes simply 10 to the power 0. 0.3427. Use your anti-log table. 0.34 under 2 and 7. Same way, 0.34 in the left hand bar, 2 at the top and 7 in the mean difference. And we get here 2202, right? Where do I apply the decimal? There's a 0 over here, right? So that means this is 10 to the power of, 2.202, because this is 0 over here, into 10 to the power of 1. 10 to the power of 0, because this is 10 to the, there's a 0 over here, 10 to the power 0. Sorry for the confusion. Log of x is 0.3427. So I write my value as 2.202 into 10 to the power of 0. Alternately, like you had done over here, there you had subtracted one value. So here you add 0 plus 1 makes 1. Count from left and you put the decimal. You can do it either way. So your answer comes out as 2.202 is the value of x. This is the value of this entire expression, not of the log value. This is the value of x. I shall be posting some questions based on this under the description box. Please try and attempt, or you can also visit the site Learning Chemistry is Easy and Fun. It's a Google site where I shall post worksheets as well as the answer sheets to questions based on logarithms. Don't worry, in the first go it will appear confusing. Go through the video once again, attempt the questions. My earnest request, unless you do it yourself, you will not get a hang of it. And secondly, if you can find somebody who needs help with logarithms, just go ahead and explain. When you are explaining, your own doubts will also be cleared. Happy studying. Please don't forget to subscribe to the channel Learning Chemistry is Easy and Fun.